Hi guys, tonight we're going to explore one of the most fascinating mysteries in all of human history. What if an advanced civilization existed on Earth long before our recorded history began? What if everything we think we know about human progress is missing a crucial chapter that's been lost to time? If you enjoy these thought-provoking sleep stories that challenge what we think we know about our world, hit that like button and subscribe for more. And leave a comment telling me what time it is where you are and where you're listening from. I love hearing from all of you around the globe. Alright, let's dive in. Beneath the rolling hills of southeastern Turkey, archaeologists carefully brush away millennia of accumulated earth from stone pillars that defy everything we thought we knew about human civilization. Göbekli Tepe, dating back nearly 12,000 years, predates Stonehenge by some 6,000 years, and the Egyptian pyramids by 7,000. Yet these massive T-shaped limestone monoliths, some weighing up to 16 tons and standing over 5 meters tall, display an artistic sophistication and engineering prowess that seems impossibly advanced for hunter-gatherers who supposedly had not yet discovered agriculture or the wheel. As the morning sun casts long shadows across these ancient megaliths, carved with intricate reliefs of lions, serpents, boars and birds, a profound question echoes across the archaeological site. What if the narrative we've constructed about human progress is fundamentally incomplete? What if, long before our recorded history began, a civilization of remarkable sophistication once flourished on this very planet, leaving behind only the faintest traces of their existence? This possibility haunts the corridors of museums worldwide, whispers through academic conferences, and challenges the very foundation of how we understand our species and our world. The implications stretch far beyond archaeology into geology, biology, climatology, and even our conception of what it means to be human. If such a civilization existed, its disappearance would represent not just an archaeological mystery, but a stark reminder of the fragility of all complex societies, including our own. Consider the vast expanse of time that separates us from the earliest evidence of human activity. Modern Homo sapiens emerged roughly 300,000 years ago, yet our written history extends back merely 5,000 years. That leaves a staggering 295,000 years of human existence largely shrouded in mystery. During the last ice age alone, which ended approximately 11,700 years ago, sea level stood 120 meters lower than today. Vast coastal plains that might have harbored thriving civilizations now lie submerged beneath hundreds of billions of tons of seawater. The Mediterranean Sea, which today covers approximately 2.5 million square kilometers, was significantly smaller during the last glacial maximum. The English Channel did not exist as we know it, and Britain was connected to continental Europe by a land bridge called Doggerland, an area roughly the size of present-day England that disappeared beneath the North Sea as the ice sheets melted. The Persian Gulf was largely dry land, and what we now call the Bering Sea was a vast plain connecting Asia and North America. If advanced civilizations had established themselves in these now submerged regions, their remains would lie beneath thousands of cubic kilometers of sediment on the ocean floor. Marine archaeologists working off the coast of India near Gujarat have discovered structures at depths of 30 to 40 meters that appear to be remnants of a planned city. Carbon dating of artifacts suggests these ruins are over 9,000 years old, predating the supposed birth of urban civilization by several millennia. The geometric patterns, the evidence of sophisticated drainage systems, and the sheer scale of the submerged complex challenge conventional timelines of human development. But the ocean floors are not the only places where evidence of a pre-existing advanced civilization might hide. The Earth's geological processes are ruthlessly efficient at erasing traces of the past. Plate tectonics recycle the oceanic crust approximately every 200 million years, carrying any evidence into the mantle where it is destroyed by temperatures exceeding 1000 degrees Celsius. The continental crust, while more stable, undergoes constant weathering, erosion, and sedimentation that can bury or obliterate surface features in mere millennia. Consider the scale of geological time and the power of natural forces. The Sahara Desert, now covering 9 million square kilometers of North Africa, was a lush savanna as recently as 6,000 years ago, supporting hippos, giraffes, and human settlements around vast lakes and rivers. Core samples from the region reveal dramatic climate shifts that transformed this green landscape into the world's largest hot desert in a geological instant. Any civilization that had developed in this region would have faced environmental pressures that could have forced mass migration or collapse. The Younger Dryas period, beginning approximately 12,800 years ago, saw global temperatures plummet by as much as 15 degrees Celsius in some regions within decades. This climate event, possibly triggered by a comet impact or massive volcanic eruption, would have devastated any existing complex societies. Ice sheets advance rapidly across northern Europe and North America, while tropical regions experience severe droughts. Ocean currents shifted dramatically, altering weather patterns worldwide. Recent analysis of ice cores from Greenland shows that during this period, precipitation levels in some regions dropped by up to 60%. Agricultural systems would have collapsed, forcing populations to abandon permanent settlements and return to nomadic lifestyles focused purely on survival. Any libraries, artwork, or sophisticated technologies would have been abandoned or repurposed for immediate needs. The geological evidence for catastrophic events in Earth's recent history continues to accumulate. The Toba supervolcanic eruption in Sumatra, occurring approximately 74,000 years ago, ejected an estimated 2,800 cubic kilometers of volcanic material into the atmosphere. This event, one of the largest volcanic eruptions in the past 2 million years, likely created a volcanic winter lasting several years and may have reduced the global human population to as few as 3,000 to 10,000 individuals. If an advanced civilization had existed before Toba, such an event would have been utterly catastrophic. The volcanic ash would have blocked sunlight across vast regions, causing global temperatures to drop by 3 to 5 degrees Celsius for several years. Agricultural systems would have failed worldwide, and without modern technology to preserve food or maintain communication networks, even sophisticated societies would have fragmented into small survivor groups, focused solely on finding food and shelter. Archaeological evidence suggests that human creativity and technical skill emerged much earlier than traditionally believed. Cave paintings in Spain dating back 65,000 years demonstrate sophisticated use of pigments and artistic techniques. The Neanderthals, long dismissed as primitive, created jewelry, used tools, and buried their dead with apparent ritual significance. If these supposedly less advanced human species possessed such capabilities, what might fully modern humans have achieved during the hundreds of millennia we have no record of? The discovery of precision-engineered megalithic structures worldwide suggests that ancient peoples possessed knowledge and capabilities we're only beginning to understand. At Pumapunku in Bolivia, stone blocks weighing up to 130 tons are fitted together with tolerances of less than 1 millimeter. The precision of these cuts rivals modern machining capabilities, yet they were supposedly created by people using only stone tools and bronze chisels. The Great Pyramid of Giza, built approximately 4,600 years ago, contains over 2 million stone blocks, each weighing between 2 and 15 tons. The pyramid's base covers 13 acres and was originally 146 meters tall. Its orientation is precisely aligned to true north within 3/60ths of a degree, a level of accuracy that requires sophisticated astronomical knowledge and measuring instruments. Recent discoveries using cosmic ray muon tomography have revealed previously unknown chambers within the Great Pyramid, suggesting that these monuments contain secrets we have not yet uncovered. The engineering required to create such structures implies not just advanced mathematics and astronomy, but sophisticated logistics, labour management and transportation systems. Yet even these impressive achievements pale beside the possibility that they represent not the beginning of human architectural sophistication, but the remnants of much older traditions. The megalithic site at Göbekli Tepe required an estimated 500 people, working continuously for decades to move and carve the massive limestone pillars. This level of social organisation and specialised labour suggests a complex society with established hierarchies, food surplus systems, and sophisticated planning capabilities. The site was deliberately buried around 8,000 years ago, carefully covered with tons of earth and rubble in what appears to have been an intentional preservation effort. Why would a society invest enormous effort to hide such magnificent structures unless they were protecting them from some anticipated catastrophe or cultural transformation? Similar patterns of sophisticated construction followed by abandonment appear worldwide. In Peru, the ancient city of Caral flourished around 5,000 years ago, featuring complex urban planning, monumental architecture, and evidence of advanced agriculture and trade networks extending hundreds of kilometers. The city supported an estimated 3,000 people and included pyramids, plazas, and residential complexes arranged according to sophisticated geometric principles. Yet Caral was abandoned suddenly, with no evidence of warfare or gradual decline. The inhabitants simply left, leaving behind artifacts and structures that would not be matched in the Americas for another 1,000 years. This pattern of sudden abandonment of sophisticated sites appears repeatedly in the archaeological record, suggesting that ancient peoples may have possessed knowledge about cyclical catastrophes or environmental changes that we have lost. The possibility of lost technological knowledge becomes even more intriguing when we consider the Antikythera mechanism, discovered in a Roman-era shipwreck off the Greek island of Antikythera in 1901. This bronze device, dating to approximately 100 BCE, contains over 30 meshing bronze gears and functions as an incredibly sophisticated astronomical computer capable of predicting the positions of the sun, moon, and planets decades in advance. The complexity of the Antikythera mechanism was not matched by any known technology until mechanical clocks began appearing in Europe over 1,000 years later. X-ray tomography has revealed gear trains with differential mechanisms that were supposedly not invented until the 16th century. The device demonstrates that ancient Greek craftsmen possessed metallurgical skills, precision manufacturing capabilities, and mathematical knowledge far exceeding what historians previously believed possible for that era. If such sophisticated technology could be created and then forgotten within documented history, what capabilities might have been lost from the much longer periods of human existence we know nothing about? The bronze required for the Antikythera mechanism needed to be alloyed with precise ratios of copper and tin, requiring trade networks spanning thousands of kilometers and metallurgical expertise passed down through generations of specialized craftsmen. Modern analysis of ancient metallurgy reveals that prehistoric peoples achieved remarkable sophistication in working with metals. The Varna necropolis in Bulgaria, dating back over 6,000 years, contains the oldest worked gold objects yet discovered, totaling over 6 kilograms of gold artifacts displaying advanced techniques of shaping, alloying, and decorative inlay work. The Damascus steel produced in the Middle East between 300 and 1700 CE possessed properties that modern metallurgists struggled to reproduce until recently. These blades could cut through European swords while maintaining their sharp edge through countless battles. The steel contained carbon nanotubes and carbide nanowires that gave it its legendary properties, yet the manufacturing techniques were lost when the ore sources were exhausted. If such advanced metallurgy could be achieved and lost within recorded history, the potential for earlier technological sophistication becomes even more plausible. Ancient peoples had access to the same fundamental physical principles that govern modern technology. They possessed human intelligence identical to our own, combined with generations of accumulated knowledge and the intense motivation that comes from daily survival challenges. The question becomes not whether ancient peoples could have developed advanced technology, but what evidence such development would leave behind and whether we would be able to recognize it. Modern civilization has created a distinctive signature in the geological record through our use of fossil fuels, nuclear technology, and industrial processes. Future archaeologists millions of years from now would find clear evidence of our existence in the form of plastic pollution, altered atmospheric composition, and radioactive isotopes from nuclear weapons testing. But what if an earlier advanced civilization had developed along different technological pathways? If they had achieved sophistication through biological engineering, sustainable energy systems, or materials science that worked with natural processes rather than against them, their technological signature might be virtually invisible to us. Consider the sophisticated understanding of biological systems demonstrated by ancient peoples. The Amazon rainforest, long considered pristine wilderness, is now recognized by ecologists as largely anthropogenic, shaped by indigenous peoples over thousands of years through sophisticated forest management techniques. These peoples created what scientists now call anthropogenic soils, or terra preta, which remain incredibly fertile centuries after their creation. Analysis of these soils reveals that indigenous Amazonians achieve soil carbon concentrations of up to 150 grams per kilogram, compared to typical rainforest soils containing fewer than 20 grams per kilogram. These soils cover an estimated 160,000 square kilometers of the Amazon basin and continue to sequester carbon at rates exceeding natural forest soils. The creation of terra preta required detailed understanding of soil chemistry, microbiology, and ecosystem dynamics. The process involved carefully controlled burning, addition of organic matter, and introduction of specific microorganisms that continue to function centuries later. This represents a sophisticated biotechnology that enhanced rather than degraded natural systems. If ancient peoples could achieve such remarkable results working with biological systems, what might they have accomplished with thousands of additional years of development? They might have developed architectural techniques using living materials that grew into desired shapes, created transportation systems based on biological principles, or achieved computational capabilities through organic processes. Such biotechnological sophistication would leave little trace in the archaeological record. Living materials decompose, organic computers return to soil, and biological systems integrate seamlessly into natural ecosystems. only careful analysis might reveal subtle patterns of species distribution or soil composition that hint at ancient intervention. The scale of potential evidence destruction becomes apparent when we consider the data storage capabilities of different materials. Modern digital storage systems degrade within decades, while even our most durable materials like steel and concrete deteriorate within centuries when exposed to natural weathering. In contrast, stone carvings and ceramic artifacts can survive for millennia, but they represent only the most basic technological applications of any advanced society. A truly advanced ancient civilization might have stored information in crystalline matrices, genetic codes, or quantum states that would be indistinguishable from natural phenomena to archaeologists lacking appropriate detection equipment. They might have developed materials that actively repaired themselves, leaving no trace of degradation, or created technologies that completely recycled themselves when no longer needed. The search for evidence of such a civilization requires expanding our definition of what constitutes archaeological evidence. Recent advances in satellite archaeology have revealed previously unknown ancient sites by detecting subtle variations in vegetation patterns, soil composition, and ground temperature that indicate buried structures. These techniques have identified thousands of archaeological sites worldwide that show no visible surface features. LiDAR technology has revolutionized archaeology by penetrating forest canopies to reveal landscape modifications invisible from ground level. In Cambodia, LiDAR surveys revealed that the Angkor civilization was far more extensive than previously known, covering over 1,000 square kilometers with sophisticated hydraulic systems supporting a population of up to 1 million people. Similar surveys in Central America have revealed vast Maya cities hidden beneath jungle canopies. These discoveries demonstrate that even relatively recent civilizations can remain hidden from conventional archaeological surveys. If modern technology is only now revealing the true extent of civilizations from a few centuries ago, how much might remain undiscovered from much earlier periods? The application of these advanced detection techniques to older geological formations might reveal evidence of much earlier human activity. Ground-penetrating radar can detect buried structures and voids to depths of 30 meters or more, while magnetometry can identify subtle variations in soil magnetic properties caused by human activity thousands of years ago. Chemical analysis of deep soil layers and sediment cores can reveal evidence of human activity through altered ratios of elements, presence of specific compounds, or changes in organic matter composition. Sophisticated spectroscopic techniques can detect trace amounts of materials that would indicate metallurgy, agriculture, or industrial processes. The challenge lies in distinguishing between natural geological processes and artificial modifications. The Earth's natural systems can create structures and patterns that appear artificial to human observers. The Giant's Causeway in Ireland, with its perfectly geometric basalt columns, is entirely natural, formed by volcanic cooling processes. The Moeraki boulders in New Zealand appear to be artificially carved spheres, but result from natural concretion processes over millions of years. This ambiguity means that evidence of ancient advanced civilizations might be hiding in plain sight, dismissed as natural phenomena because we lack the analytical tools or theoretical framework to recognize artificial origins. The key lies in identifying patterns that are statistically unlikely to occur through natural processes alone. Recent analysis of the Bosnian pyramid complex has generated intense debate within archaeological circles. Proponents argue that the hills near Visoko display geometric properties too precise to be natural formations, with angles and orientations that suggest artificial construction. critics counter that the features result from natural geological processes combined with selective interpretation of data. This controversy highlights the challenge of identifying very ancient artificial structures that have been heavily weathered and partially destroyed by natural processes. The debate requires sophisticated statistical analysis of geological data, advanced materials testing, and careful consideration of what constitutes acceptable evidence for extraordinary claims. The implications of discovering evidence for an advanced prehistoric civilization would extend far beyond archaeology into fundamental questions about the nature of human development and the stability of complex societies. If such a civilization existed and subsequently collapsed completely, it would demonstrate that technological advancement does not guarantee long-term survival. Current climate models suggest that human activities are altering atmospheric composition at rates not seen in the geological record for millions of years. Atmospheric carbon dioxide concentrations have increased by over 40% since the beginning of the Industrial Revolution and continue rising at accelerating rates. Global average temperatures have increased by approximately 1.1 degrees Celsius since 1880, with the rate of change accelerating in recent decades. If these trends continue, they could trigger cascading feedback effects that make large portions of the planet uninhabitable within centuries. The West Antarctic ice sheet contains enough water to raise global sea levels by approximately 3.3 meters, while the complete melting of the Greenland ice sheet would add another 7.4 meters. The collapse of these ice sheets appears increasingly likely as surface melting accelerates and warm ocean water penetrates beneath the ice. Such sea level changes would submerge coastal cities housing hundreds of millions of people and eliminate vast areas of agricultural land. The economic disruption would be unprecedented, with damage estimates in the hundreds of trillions of dollars. Social and political systems would face pressures that could lead to widespread conflict and the collapse of international cooperation. A prehistoric advanced civilization would have faced similar environmental challenges, whether from natural climate cycles, catastrophic events, or the unintended consequences of their own activities. Their response to these challenges, whether successful adaptation or catastrophic failure, could provide crucial insights for our own species as we confront environmental pressures of unprecedented scale. The study of civilizational collapse has revealed common patterns across different cultures and time periods. The Maya civilization at its peak, around 900 CE, supported several million people across sophisticated city-states with advanced astronomy, mathematics, and engineering. Yet within 2 centuries, most Maya cities were abandoned, with populations declining by over 90% in some regions. Research suggests that the Maya collapse resulted from a combination of environmental stresses, including severe droughts lasting decades, combined with social and political factors such as warfare between city-states and the inability of ruling elites to adapt to changing conditions. The sophisticated knowledge that had enabled Maya achievements was lost as social systems broke down and populations dispersed. Similar patterns appear in the collapse of the Bronze Age civilizations around 1200 BCE, when advanced societies across the eastern Mediterranean simultaneously experienced catastrophic decline. The Mycenaean civilization in Greece, the Hittite Empire in Anatolia, and the New Kingdom of Egypt all suffered severe disruption within a few decades. Archaeological evidence suggests that this Bronze Age collapse involved a combination of natural disasters, including earthquakes and volcanic eruptions, invasions by mysterious sea peoples, internal social conflicts, and the disruption of trade networks that these civilizations depended upon for essential materials like tin and copper. The speed and completeness of these collapses demonstrate how quickly sophisticated societies can lose the knowledge and organizational capabilities that enable their development. Within a few generations, populations that had possessed advanced metallurgy, complex writing systems, and monumental architecture were reduced to subsistence farming with minimal material culture. If a much earlier advanced civilization had experienced similar collapse, perhaps on an even larger scale, the loss of knowledge would be virtually complete. Oral traditions might preserve fragments of information for a few generations, but without writing systems and formal educational institutions, sophisticated technical knowledge would disappear rapidly. The recovery from such collapse could take millennia, during which the evidence of the earlier civilization would be steadily erased by natural processes. By the time human societies again achieved sufficient sophistication to conduct archaeological investigations, only the most durable traces would remain, and these might be so altered by weathering and geological processes as to be unrecognizable. This possibility suggests that our current archaeological methods may be fundamentally inadequate for detecting evidence of very ancient advanced civilizations. We have developed techniques optimized for finding relatively recent sites with preservation conditions similar to those we understand from historical periods. Our theoretical frameworks assume gradual technological development and social complexity increasing steadily over time. But what if human development has been cyclical rather than linear? What if our species has achieved high levels of sophistication multiple times, only to lose that knowledge through catastrophic events or civilizational collapse? The archaeological record might contain numerous instances of apparent technological anachronisms that we dismiss because they do not fit our expectations about when certain capabilities should have emerged. The U-parts, or out-of-place artifacts, represent objects that appear in archaeological contexts much earlier than conventional chronology would suggest possible. While many can be explained through misidentification, contamination of archaeological sites, or hoaxes, others remain genuinely puzzling. The Koso artifact discovered in 1961 inside a geode supposedly formed over 500,000 years ago contained what appeared to be a modern spark plug. Later analysis revealed it was likely a 1920s champion spark plug that had become encased in hardened clay rather than natural rock formation. But the initial discovery highlighted how easily genuine anomalies could be misinterpreted. More compelling are artifacts like the Saqqara bird, a wooden object from ancient Egypt dating to approximately 200 BCE that bears striking resemblance to a modern aircraft. While Egyptologists classify it as a bird figurine, aerodynamics engineers have noted that its proportions and design features are consistent with glider aircraft principles. The Nazca lines in Peru present another puzzle, with geometric patterns and animal figures covering over 450 square kilometers of desert and only fully visible from aerial perspectives. These designs, created between 400 and 650 CE, required sophisticated surveying techniques and coordinated labor over vast distances, yet served no apparent practical purpose for a ground-based civilization. Some researchers have suggested that the Nazca lines indicate knowledge of flight, or were created for aerial observation, while others propose they had astronomical or religious significance. The precision and scale of the lines demonstrate capabilities that challenge conventional understanding of pre-Columbian American civilizations. These anomalies might represent not evidence of ancient high technology, but rather the sophisticated application of principles and techniques that we underestimate because we approach them with modern assumptions about technological development. Ancient peoples may have achieved remarkable results through methods completely different from our own approaches. The possibility of radically different technological pathways becomes clear when we consider that human intelligence has remained essentially unchanged for hundreds of thousands of years. The cognitive capabilities that enable modern scientific and technological achievement were possessed by humans throughout the entire period of our species' existence. What has changed is the accumulation of knowledge, the development of formal educational systems, and the creation of material infrastructure that supports technological development. But given sufficient time and appropriate circumstances, earlier human populations could potentially have achieved similar or even superior results through different methodologies. Recent research in cognitive archaeology suggests that human symbolic thinking and abstract reasoning capabilities emerge much earlier than previously believed. Evidence for sophisticated numerical concepts, artistic expression, and complex tool manufacture appears in archaeological sites over 100,000 years old. The Blombus Cave in South Africa has yielded ochre pieces with geometric engravings dating back 75,000 years, representing some of the earliest known symbolic art. These patterns demonstrate abstract thinking, planning capability, and the ability to create and recognize meaningful symbols. Such cognitive capabilities, given tens of thousands of years of development, could potentially have supported technological achievements we have not yet considered. Ancient peoples might have developed computing systems based on biological processes, achieved flight through understanding of aerodynamics principles we have not yet discovered, or created energy systems that worked with natural forces in ways we have not imagined. The search for evidence of such achievements requires expanding our scientific methodologies beyond conventional archaeological approaches. We need to develop techniques for detecting technological signatures that might be completely different from those produced by our own civilization. This research program would require interdisciplinary cooperation between archaeologists, geologists, climatologists, biologists, physicists, and computer scientists. Advanced analytical techniques from multiple fields would need to be applied systematically to geological formations, archaeological sites, and natural systems that might preserve evidence of ancient technological activity. Machine learning algorithms could be trained to recognize patterns in satellite imagery, geophysical data, or chemical analyses that might indicate artificial origins. These systems could process vast amounts of data to identify subtle anomalies that human researchers might overlook. The potential discoveries could revolutionize our understanding not just of human history, but of the fundamental nature of technological development and civilizational stability. If we found evidence that our species had previously achieved high levels of sophistication, it would demonstrate that intelligence and creativity are not sufficient to guarantee long-term survival. Such a discovery would also suggest that the knowledge and capabilities we consider uniquely modern may actually represent the rediscovery of principles and techniques that were once known but subsequently lost. The humbling realization that we may not be the first advanced civilization on our own planet could provide crucial perspective on the challenges we face and the importance of preserving knowledge and maintaining sustainable relationships with natural systems. The implications extend beyond Earth to our understanding of the potential for intelligent life throughout the universe. If advanced civilizations can rise and fall completely within single planets, leaving little trace of their existence, the cosmos might be filled with worlds where intelligence has emerged multiple times, achieved remarkable sophistication, and then vanished so completely that later, intelligent species have no knowledge of their predecessors. This possibility, sometimes called the Silurian hypothesis, after the intelligent reptiles in Doctor Who, suggests that the apparent absence of evidence for extraterrestrial intelligence might result not from the rarity of intelligence, but from the tendency of advanced civilizations to either destroy themselves or leave signatures so subtle that we lack the capability to detect them. As we continue developing more sophisticated analytical techniques and expanding our theoretical understanding of what technological development might look like under different constraints, we may eventually discover evidence that fundamentally changes our conception of human history and our place in the universe. The ancient stones of Göbekli Tepe may represent not the beginning of human architectural achievement, but a late echo of much earlier accomplishments that lie buried beneath the accumulated sediments of geological time. Until then, we can only marvel at the sophistication that our ancestors achieved within recorded history, and wonder what greater achievements might lie hidden in the vast expanse of human existence that remains largely unknown. The possibility that we are not the first advanced civilization on Earth serves as both a humbling reminder of the impermanence of human achievements and an inspiring suggestion that our species possesses capabilities we have yet to fully understand or appreciate. The search continues, driven by the same curiosity and determination that enabled our ancestors, whether recent or ancient, to transform from small bands of hunter-gatherers into creators of monuments that still inspire awe thousands of years after their construction. In that continuity of human achievement and aspiration, we find both our connection to the past and our hope for the future, regardless of what secrets the Earth may yet reveal about the civilizations that came before us.